Okay, welcome back. So we will continue with the second subtopic, 1.2, electric field. Okay, so electric field is defined as a region of space around isolated charge where an electric force experiences if a positive test charge placed in the region. Okay, so usually we will assume there is a positive test charge around. Okay, so for example, if let's say this is a positive point charge, okay, and we put this is a test charge, okay, so if you put the test charge near to the positive point charge, this positive point charge will push, okay, will push a positive test charge upward. Okay, so electric field around charges can be represented by drawing a series of lines. These lines are called electric field line. Okay, so for example, if let's say this your point charge is a positive point charge, okay, and there is a positive test charge. So what happens is this point charge will push, okay, will try to push the positive test charge. Okay, so your line is going upward. Okay, it's going upward. Okay, we assume it is going upward. Okay, so this is your electric field line. Okay, electric field line. If this is your point charge is a negative point charge, and we put a positive test charge, okay, around. So what happens is your electric field line will acting inward. Okay, meaning that it is like assumes that it is pushing. Okay, it's pulling the positive test charge inward. Okay, near to the point charge. So your electric field line for negative point charge is acting inward. Okay, is acting inward. Okay, if let's say we have two equal opposite point charge, okay, we have two equal, if let's say this is positive Q, this is a negative 1Q. So what happens is the electric field line for point charge, positive and negative will be the same. For example, this is 1, 2, 3, 4, 5, 6, 7, 8. For negative charge also 1, 2, 3, 4, 5, 6, 7, 8. Because both are equal, okay, equally same charge. Okay, so your electric field line will come out from positive to enter negative charge. Okay, come out from positive, enter negative point charge. If both are similar charges, meaning positive, positive or negative, negative. Okay, so you will see this type of diagram where both of them can electric field line for both charges are not connected. Okay, if let's say positive, positive, okay, the electric field line will go upward. Okay, if this is a negative and negative, okay, it will not touch to each other as well. Okay, but the arrow will enter to the negative charge. Okay, negative charge. Okay, next one. If both are unequal, okay, the first one is negative 1Q, the second one is positive 2Q. Okay, so for negative Q, we only have 1, 2, 3, 4, 5, 6 line. Okay, for 2Q, we will have double up, meaning that we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 line. Okay, because the charges is double up. Okay, and the line similar from positive to negative, positive to negative. Okay, for parallel plates, okay, line actually you will have a parallel line, okay, where your line is from positive plate to negative plate. Positive plate come out, enter negative plate. Okay, so the directions of electric field is tangent to the electric field line at each point. Okay, so you must be able to draw or sketch the electric field line. If let's say in an exam they ask you to draw. Okay, next one is electric field strength, or we call it intensity. So it's defined as the electric force per unit positive charge that acts at the point in the same direction as the force. Okay, so meaning that if let's say they ask you to define in the UPS, in UPS, these questions will come out in UPS. If they ask you to define what is electric field strength, okay, you must define as E equals to force over Q. Okay, force per unit positive charge, okay, F over Q. Okay, so you must define as force per unit positive charge. And it is a vector quantity, meaning that you need to give magnitude and also give the direction. Okay, so the method to find the electric field actually similar like just now, the 1.1 forces. Okay, okay, the unit of the electric field is Newton per Coulomb. Newton per Coulomb because our E is equals to F over Q. So it equals to Newton per Coulomb. Okay. Or sometimes you also can write the unit in volt per meter because your E we also can write as delta V electric potential over distance. Okay, so it's volt per meter. Okay, so both also acceptable for electric field. Okay, next. Okay, since our F equals to KQQ over R square, we substitute into the equation force per unit point charge. So our point charge and point charge, we can cancel each other. So finally, our E will equals to KQ. Q is the point charge over R square. Okay, over R square, where Q is the point charge. Okay, so we can use these equations to find electric field for a point charge. Okay, next one. Okay, noted that the directions of electric field strength depends on the sign of the point charge only. Okay, because our E is equals to Q, the point charge, over R square. Okay, whereas for force depends on both sign because our force is equals to K Q1 Q2 over R squared. So it depends on Q1 and also Q2 whether it is similar or opposite charges. Okay, so we look at the diagram on the next page. Okay, so remember your E will always refer to the point charge. Okay, E will always refer to the point charge, but F must refer both. Okay, both meaning that you must refer point charge and also you must refer test charge. Okay, so you refer to the first diagram. Okay, this is a positive point charge, meaning that your electric field will go outward because it is a positive point charge. But if you refer to the force, this is point charge is positive, your test charge also positive. So positive, positive, your forces will push outward or repulsive force. So this is first diagram. Okay, second diagram. Point charge is positive. So meaning that the electric field line also will going upward because we only refers to the point charge. For electric force, your point charge, if let's say it's a negative, so positive, negative, it will attract into the point charge. Okay, so this is the diagram for a negative point charge. A negative test charge. Okay, diagram 3. Your point charge is negative. Point charge negative meaning that your electric field will attract into the negative point charge. But if let's say your test charge is positive, so negative point charge, positive test charge, negative, positive, it will attract into, okay, to the point charge. Okay, so this is the diagram for a positive test charge. Diagram number 4 is negative point charge. So negative point charge, your E, of course, will acting inward, electric field line. Okay, if your test charge is negative, negative, it will experience repulsive force. So your test charge will push outward. Okay, so this is the differences between the electric field line and also electrostatic force. Okay, next. Example 4. Estimate the electric field strength at point X that is 10 nanometer from the gold nucleus, which is assumed to be a point charge. Okay, so if let's say we have a point charge gold, okay, so if let's say this gold is a point charge, so we want to find at 10 nanometer, okay, 10 nanometer, the distance is 10 nanometer, okay. So we want to find what is our electric field strength at 10 nanometer away from the nucleus. Okay, so you can calculate E equals to KQ, where Q is the point charge, over R square. Okay, so your K is 9 times 10 to the power of 9. Q is the point charge, where they give you 79 nucleus only. Okay, so our equation for Q is equals to number of nucleus times the charges. Okay, so your number of nucleus is 79 and the charges for positive or negative will be the same, 1.6 times 10 to the power of negative 23. Okay, so this is how you find the charges, okay, for a nucleus. Okay, so after that you calculate, you substitute inside, you will get 1.264 times 10 to the power of negative 17. Okay, over 10 nano. Okay, and remember, squared up. Okay, so the electric field strength that you get is 1.1 times 10 to the power of 9 Newton per coulomb. Okay, you may pause your video if let's say you haven't calculated. Okay, so you can pause the video to do the calculation first. Okay, next one. Okay, they will ask you to find the electric force. Okay, so since we know that your E is equal to force per unit test charge. Okay, so we can rearrange back F equals to EQ. Okay, where your Q is the test charge to nucleus. And again, just now, if you want to find the charge, you must use number of nucleus times charge 1.6 times 10 to the power of negative 23. Okay, so it's 2 times 1.6 power of negative 20. Sorry, not 23, it's 19. It's 19. Okay, it's 19. 1.6, sorry. 1.6 times 10 to the power of 19. This one also wrong. Okay, sorry. Okay, so charge for positive or negative charge is actually 1.6 times 10 to the power negative 19. Okay, 19. Okay, so you substitute inside. E is the value that you get just now, 1.1 times 10 to the power of 9. And Q is the test charge. Okay, if let's say we put a test charge at that point, meaning that your test charge is 2 times 1.6 negative 19. Okay, so the force experienced by that test charge will be equals to 3.5 times 10 to the power of negative 10 Newton. Okay, so meaning that if let's say we put a helium, okay, helium is the test charge, okay, that we put at this point, we put at here. Okay, so it will experience a force 3.5 times 10 to the power of negative 10, okay, Newton experienced by this helium. Okay, if let's say we put at this point. Okay, so this is the difference between the test charge and also a point charge. Okay, point charge give inference. Okay, test charge is the charge that we want to test what happened to the test charge. Okay, next question is number 2. Example number 5. Okay, example number 5 here, we have 2 charges and also 1 point. Okay, so the question say, ask us to sketch the electric field strength diagram at point P. So point P is our superstar. Okay, is our superstar. This is the point that we want to find. Okay, so we want to find what is the electric field line experienced by this point P. So usually when we want to draw, we assume, we assume, kita anggap lah ada satu positive test charge at here. Okay, we assume where negative, and this is the test charge. This is the test charge, positive. This is the point charge. So negative, positive, our point P electric field will attract, to the left. Okay, so we label it as E P attract by charge 1. Okay, now we have another point charge that also will give inference. So positive test charge, negative point charge. So it will also attract to the right, E at point P attract by charge 2. Okay, so meaning that at point P, you will experience 2 electric field line. Okay, so we can draw it as at point P, we have EP2 and we also have EP1. Okay, so this is your point P. Okay, this is point P. So what happened is this is only X component. So first, what should we do? We find the magnitude first. Of course, we must find the magnitude first. Okay, so we must find the magnitude first, where we need to find EP1 and we modulus KQ1 over R square. And then we find EP2 KQ2 over R square. Okay, so after that, what should we do? Okay, you calculate first. You substitute all the value. EP1, you will get 1.88 times 10 to the power of 6 Newton per Coulomb. Okay, and EP1, of course, is to the left, because it's attract to the left. And then EP2 is, after calculate, you will get 5 times 10 to the power of 5 Newton per Coulomb, and it is towards the right. Okay, so 5 times 10 to the power of 5 to the right, 1.88 times 10 to the power of 6 Newton per Coulomb acting on the left. So the resultant on point P will be EP2 positive because it's to the right, plus negative EP1 because it is to the left. Okay, so you will get the answer is negative 1.38 times 10 to the power of 6 Newton per Coulomb. Okay, negative here shows that final, direction is towards left. Okay, negative here shows that it will acting to the left. Okay, again, if we put a test charge, okay, so this is a test charge, positive 1 microcoulomb at point P. So what happened? Okay, we need to find the electric force. So E equals to F over Q. Okay, so your F equals to EQ, where Q, this Q is actually is the test charge. Okay, it's the test charge that we put on that point, so that we want to check whether it is what happened to that test charge. Okay, so E is equals to negative 1.38 times 10 to the power of 6 And the test charge is positive 1 microcoulomb. Okay, so finally you will get negative 1.38 Newton. Of course, again, negative here shows that it will attract to the left. Okay, so this is example number 5. Okay, next one. Okay, we want to determine the distance of point A from Q1 where the electric field intensity is equal to 0. Okay, so just now negative Q1 and also we have also negative Q2. Okay. Okay. So okay, so your Q1 wait. Okay. So you need to find a new point where you will get the E resultant is equal to 0. Okay, so okay, this is point A, point A. Okay, and this is X. This is just now is 42, right? Okay, so it's 42 or 0.42 minus X. Because just now the total distance between the Q1 and Q2 is 42. Okay, 42. Okay, 42. So now we want to calculate. In order to get resultant, okay, we assume first, we assume there is a positive test charge at here. Okay, so negative, positive. Okay, this is our superstar. Well, we are referring to this point. So negative, positive, it will attract. So we write as EA1. Okay, positive, negative, it will also attract. So this is EA, point A, attract to charge 2. Okay, so our equation is EA2 positive plus negative EA1 and it must equal to 0. Okay, so in order to get equilibrium or electric field intensity is equal to 0, your EA2 must equal to EA1 modulus, meaning that the magnitude must be same. Okay, magnitude mesti sama. Okay, so we write KQ2 over R squared equals to KQ1 over R squared. Okay, K and K we cancel. Q2 is 5 times 10 to the power of negative 6. The distance is Q2 is 0.42 minus X squared. Okay, Q1 3 micro and the distance is X squared. Okay, so the answer, okay, try to calculate out. The answer X is equals to 0.183 meter. Okay, so this is example number 5. Okay, example number 6. This is your homework. Okay, you must submit. Okay, you must submit the homework. Okay, you must submit in our Google Classroom. Okay, so before that, you must find out first the electric field strength at point M. So M is our superstar. Okay, and usually when you want to do this type of questions, you must assume first there is a positive test charge at here. Okay, so that is easier for us to check the directions. Okay, so Q1 and Q2 meaning that we have 2E. Okay, negative and our test charge is a positive. So negative, positive, our test charge will attract. Okay, will attract. This one, of course, will go down lah. Okay, so this one is E1. Okay, positive, 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 repulsive force. So our test charge will push, okay, and of course our Q2 will push, okay, will push away. It's a repulsive force. So we will write E2, okay, or you want to write E1, EM1 or EM2 also can, okay. So we sketch at A, okay, meaning that this is our EM2 and here is our EM1. Okay, so you must find the angle here. Angle. What is the angle? You can use tangent theta, okay, to find the angle. 3/4. You find the angle first. Okay, so after you find the angle, what should you do? This one you must go back to chapter 1, semester 1. Okay, so you need to find EM1 modulus. You must find EM2 you modulus. And then this is step 1. Step 2, you must resolve into x and y component. Okay, you must resolve into x and y component. Okay, so you must draw a table, easier for you to resolve. So x and y component. Step 3, you must find the magnitude. Okay, step 4, you must find the direction. Okay, by using tangent theta, and then you will modulus. Because this is E, so we write EY over EX. Okay, and step 5 is you need to sketch. Okay, you need to sketch the graph. Okay, step 5. Okay, you need to sketch the graph. Okay, from X and also Y axis. Okay, so you need to sketch the graph. Okay, at which component? Okay. This is just now 1. Okay, this is sketching. Okay, so step 1 until step 5 actually is you need to answer for questions B. Okay, so that's all for 1.2. Okay, thank you, class. Okay, after finish, please send in your homework in our Google Classroom.